Hi guys, we are working on our machine learning end-term project, and our teammates are Akansha, Harshita, and Shekhar. So our project we are developing on a SMS spam filter. So it is a very common NLP problem, which is very popular. It can be an SMS messages or email spam messages. There are various spam analyses in a various fields. So we are introducing in a similar manner. So we have a set of spam collection of messages that consists of 5,572 of English messages. They are tagged according to the spam or ham. So we have chosen two attributes. One is SMS messages and another one is labels that consist of spam or ham. So first step, we are proceeding with data pre-processing. Why we are doing that is whether to classify the messages ham or spam, we have to do some data cleaning because it is a raw data. So first we will remove the stop words with white spaces. Then we will remove the punctuations. Then after cleaning those two, we'll make sure that we'll clean all the messages that consist of white spaces. Then we will proceed to the tokenization part. Tokenization is nothing but it splits the messages of paragraph into smaller words. So it can assign one meaning. So after that process, we will continue with the lemmatization and stemming. So both are text normalization techniques which are used to describe the words or documents into further processing. So next we are starting with the word cloud. Word reviews the most frequently used words spam. So these words are usually chosen based on the importance and can give insights that themes and tactics that used by the spammers. So we can see in ham SMS, we can see there are bigger words in the cloud image. So the bigger words which are visible is frequently used words. So the words come, known, see, don't are the frequently used words in ham. Similar to spam, we can see call, claim, weak, replay, etc. And next slide will be continued by our teammate Akansha Raj.
Thank you, Harshita. And so to build a machine learning model, we need to convert all the text data into numbers because machine does not understand textual data. Hence, we have different approaches to convert this textual data into numbers. First approach, which I'm going to talk about, is vectorization approach of term frequency. Term frequency is a common approach to vectorize the data in the field of natural language processing. The idea behind this approach is to represent the text as a vector of term frequencies where each dimension in the vector represents the number of occurrences of a particular word in the text. Next approach I'm going to consider is term frequency inverse document frequency. It is nothing but the extension of term frequency, and it aims to capture the relative importance of each word in a text document compared to all the documents in the dataset. It gives importance to the rare words that is occurred in the document. Next vectorization approach is uh, word to vec. It is also another approach for vectorizing text data in the field of natural language processing. It was developed by Google and was published a research paper in 2013. What happens basically is that there is something called Google word to vec embeddings, which consist of uh, a corpus of words. From the text corpus, we will consider each word and convert them into 300 dimension vector based on the similarities of the word that is present in the Google word to vec corpus. Finally, we will be converting the individual vectors for all SMS into a data frame. We have also considered one vectorization approach, which is a heuristic approach, that is the presence of phone numbers. For this, we have created a user defined function to identify the presence of phone number. So what we have seen is mostly spam SMSs contained phone number. So we have given the label to spam messages as 1 and ham messages as 0. Now coming to dimension reduction, we have performed dimension reduction using PCA. PCA on term frequency matrix, term frequency inverse document vectorization, in which we have seen that after performing a PCA on term frequency matrix, the dimension got used 7,990 to 1,987. Similarly, on term frequency inverse document frequency, when we applied PCA, the dimension got reduced from 7,919 to 2,665. And also on word to vec model, which when we applied PCA, the dimension got reduced from 300 to 100. 196. We also considered one more dimension reduction technique, that is by proportion. In this, we will be removing terms that is contained in less than 0.01% of the documents. Next is the visualization of my principal component analysis on term frequency vectorization approach and term frequency inverse document vectorization approach. Next slide would be explained by my friend Sekhar.
Yeah, thank you, Akansha. So, like with respect to the previous steps which you have done, text pre-processing and the vectorization approaches, and after that PCA we have done. So now we come to the step of model fitting. So now here the aim is to perform the classification method so as to predict whether it is the given message, given SMS is a spam or ham, like normal message. So here how we are proceeding is like we have taken the 4 vectorization approaches, and we have taken 5 classification models, like namely logistic regression, support vector classifier, gradient boosting, random forest, decision tree, like that. So, and there are two pieces, like one is a PCA dimensionality reduction, another one is a percentage proportion reduction. So we have clubbed all these together into different combinations, and we have performed around 38 machine learning models. So out of the 38, now in this presentation, we are going to showcase the top 10 performing models. So this is the first model which was performed on TF-PCA vectorization on logistic regression model. So if you look at the confusion matrix, which is a performance metric for this model, so actually we are focused about the false positives, like which are the 16 in this case. So basically, so we need to decrease it as much as possible. That means the spam messages should be clearly identified. The spam should not be mistreated as a normal message. So that is our target. So we'll look into it. So the F1 score is taken as the main evaluation parameter. So because it takes the balance between the recall score and the precision. So coming to the second model, then we have observed on the TF vectorization and the logistic regression model. So this is also performing similar to the first model. So then proceeding with the third model, TF-PCA vectorization on bagging classifier. So in this particular scenario, the bagging classifier doesn't seem to be working that much better relative to the logistic regression model. With the, if you look at the performance scores, the F1 score is also a little bit less compared to the previous models. So then coming into the fourth model, here we have used vote to vector vectorization on support vector classifier model. So this is again like on par with the first two models which we have done a DF vectorization with logistic regression. So but the F1 score is little bit less. So then coming to the model 5, we have done vote to vector vectorization on random forest classifier. Here again the spam, the false positives got increased to 23, and the F1 score also slightly reduced to the 0.85. So then coming to model 6, then DF vectorization with random forest classifier. Here random forest classifier doesn't seem to be performing much for the classification of the spam message. The false positives is very high, but the false negatives are completely eliminated. Then coming to the model 7 TF-PCA on gradient boosting classifier, this is also performing good on par with the TF-PCA with logistic regression. But the F1 score is less. That means that there is no balance between the recall score and the precision. Then coming to the model 8 TF-IDF vectorization on random forest classifier, this is the false positives are very high, 28. So then moving on to the next model, DF-PCA with random forest classifier, this is also not performing better compared to the previous models. Then TF-PCA on support vector classifier, this is performing on par with the initial models. So then coming into the best performing model, we have considered the TF vectorization on logistic regression with a hyperparameter tune. So the final best performing model metrics are giving the accuracy score as 0.97. But for this case scenario, we'll take the F1 score as the best performance metric because it will get the balance between the recall and the precision. So it gave 0.9, which is the highest among all the performed models. So then coming into the conclusion, so here our best performing model was TF vectorization on logistic regression with hyperparameter tune. So on the train data, it gave 0.9 to F1 score. Then on the test data, it gave 0.9 F1 score. So this is the best performing model in our case scenario with accuracy score also 97.6%. So then coming into the conclusion about the overall conclusion, the inference from the project work that we have done. So we have done various factorization approaches. Then we have done a dimensionality reduction. So like one thing which we think the future aspect for this project is instead of just the presence of one number, if we can take some more heuristic features like presence of some words like call, claim, reply, free, those kind of words, if you club with the presence of phone number, then that would be give chances for like more opportunities for to build a more rigorous model. So that is one key takeaway from this analysis which we have done. So then thank you, that's it.